Okay, well, continuing on what we were just talking about, a modal operation, we have an example here. So we have G81 x1.00 y2.00 z minus 0.5 r 0.375 s 2000. And so what we're trying to do is drilling a series of holes. Programmers can use one of the three drilling cycles, G81, G82, or G83. G81 is a drill cycle without PEX. The machine rapids to the XY location, drills a 0.5 deep at 2000 RPMs, then retracts to 0.375 above the reference plane. Question, now the next command line reads x1.500. What happens after reading it? It repositions, drills, then retracts. Now enter x2.0, y 3.0, z minus 0.625. It positions again, but drills to a depth of minus 0.625 deep and then retracts to 0.375 again. So you can see it remembers the last state. And so in some ways, this can simplify the programming. So a couple other things that for a trade tip, as long as the routine is in effect, subsequent command entries need only be data that changes, new position, new depth, and so on. Replay, it's critical to cancel the routine with a G80 command after all the holes are drilled. Control by control, other commands might cancel G81 as well. On many, but not all, a tool change does the job, while on most controls, the M02 or M30 program and cancels routines. For custom cycles, many controls are updatable through the internet or other communication to accept new cycles for a specific routine. And some also offer the ability to compile your own cycles. For branching logic loops and subroutines, subroutines are just programs that contain all regular commands used in any other program. They are subroutines when called upon and used by other parent programs. They save time by repeating groups of commands. So here's an example. Suppose you were machining an instrument panel for cutouts all the same. The center cutout and screw mounts holes around it could be written just once. And so here we're going to have some code that's going to be done more than once. So for example, you could locate over the center of each cutout, then call the subroutine that machines that cutout. Now repositions to the center of the next cutout and calls the subroutine again. So the question you might want to be thinking about here, there's something missing in this explanation. Or what is that? The clue is thinking about G90 or G91. And so you might want to be looking up those codes and be thinking about that and come up with what you think is the best answer. So for loops, suppose you want to drill one hole in a large batch of parts, one after the next. Write a program with the commands needed, including a program encode. But one line before the end, command the program to branch back to the beginning of the commands. Among the starting commands would be M00 to halt while the new part is put into the vise. Touching the cycle again, the loop would continue. So here we're seeing this type of looping behavior that we would like to have. So there's two kinds of loops. The drill routine is called a dumb loop or an uncounted loop. It goes on forever if not stopped by operator action. A dumb loop is handy for warming up your machine on Monday. Write and save several that allow or withhold various access moves, then load and run the one that doesn't interfere with the setup. Let it exercise the machine's accesses as you get ready to work. In terms of some shop talk to consider, loops get their names from the paper tape days when we literally glued the ends of the front to create an endless loop of tape that ran forever, no rewinding. And so maybe that is something that might be familiar to a few of you, or you can be searching on that about that idea on the internet. For smart loops, these loops work the same, but they terminate after a given number of repeats of the loop. And after satisfying the counter code, the control continues to read command lines immediately after the loop's end. You can also have nesting, and so subroutines can call up other subroutines. Subroutines can call up smart loops. And so here we can get into some more elegant and complicated logic flow. A smart loop can be called inside another smart loop. These are called nested routines. As you get all the facts in the text, imagine how many ways one could combine the two techniques. In terms of a trade tip, some control will allow logic nesting to 3 levels deep and others more, up to an unlimited number of nests on some. Okay, we'll pause for a second and I'll just finish up with this last quick module.